Geometers and seekers of general truths, let us look at these two examples where we are solving problems with kites. Okay? So remember, a kite, like this one right here, has two sets of congruent side lengths, but those side lengths that are congruent are always touching each other. So MJ and KJ are congruent and touching, ML and KL are congruent and touching. And in these two problems, we're asked to solve a specific question with specific numbers, but like good mathematicians and geometers, we should take this opportunity to extend on the ideas that are in this section. What I mean by that is, let's not solve this problem right away. Let's just ask ourselves, what information can we deduce from the picture that's given? What properties can we learn from the particular figure that we have here? And then after we learn some properties about the kite, we can answer these questions relatively quickly. And one of the first things I hope you can see is that angle M and angle K look like they're equal to each other. We really want them to be equal to each other, because then life would be really easy. But we can't simply just say that. We have to reason through it a little bit. Now, fortunately, the reasoning isn't too hard. So one thing we can start out by doing is just cutting this picture into two smaller triangles. And you see I have a triangle on the left and a triangle on the right. They are, in fact, the same size and the same shape. So I'm going to make this claim here that triangle JML is congruent to triangle JKL. And you can see that they're congruent by side, side, side. They each have a segment, JK and JM, that are congruent to each other. Another set of segments, ML and KL, and then the segment in the middle here. Now, we'll go back and fill out the details of that in just a minute. But from there, we can extend on that, and we can say that the measure of angle K and the measure of angle M must be equal to each other. Okay, so we can extend on this and say that the measure of angle M and the measure of angle K are in fact congruent to each other because of CP/CTC. Congruent, or corresponding parts of congruent triangles are congruent. So from there, we can say that this angle here, angle K, must be 88 degrees because it is the same measure as angle M. Now, let us take this a step further. We can say a few other things, and let me pick a different color here. We can say that these two angles down here are congruent to each other for the exact same reason, right? So, angle JLM is congruent to angle JLK. And that means then that each of these, if we split this picture, that this angle here must be 60 degrees. Okay. And then these angles up here in our picture here, they are also congruent by the exact same reason. So angle KJL is congruent to angle MJL for the exact same reason. So in our picture, if you look at this triangle here, you have an angle of 60, an angle of 88, and so the smaller angle up here must be 180 minus 60 minus 88 degrees, which turns out to be 32 degrees. And so the other angle on the other side of that must also be 32 degrees because they're congruent to each other. So that means the measure of angle MJK must be 32 plus 32, or 64 degrees. So we have our answers now. The angle K was 88, and angle J, or MJK, was 64 degrees. And notice here, we've not only answered the question, but we've also deduced some additional information about this, all kites, right? So that two of their opposite angles here are in fact congruent to each other. So now I'll end this video here, and we'll look at the next video where we build on these ideas to try and solve this problem here. This time we are given some side lengths, or just some sides, some lengths, and we want to figure out the side lengths of the kite.